Today, let's talk about private games. When you want to host a game competition at a game expo, Discord server, or in a community, you may want to create a private game with a short numeric code. Player can join a game by entering this code. If player use character from different languages, it could cause issues. Also, we don't want player who join with the code to know the details of a private game session. To solve this, we use AWS Lambda function to generate a unique 8-digit private game code and create a game session. Then we connect this Lambda function to the game client through an AppSync GraphQL web API. AWS documentation refers to this as a client service. When designing a system that may have issue because of player actions or need hidden information, we should restrict what actions player can perform. We can run the sensitive part of the system codes on AWS Lambda or other cloud functions to set limits on the input parameters to prevent these issues. In our project, we will use 8-digit numerical as the private game code. It is easy to share, is a simple to enter, and hard to duplicate. To create a private game, we first generate a 8-digit code using AWS Lambda. Then we create game session using this code. To ensure each code matches only one game session, we use the 8-digit code as an identity token. We also create a game player session for this creator, allowing them to join a game immediately without additional request. After creating a session, we send back the 8-digit code, game session ID, and a server IP address with port to the client. The 8-digit code is displayed on the creator's client UI so they can share it easily. To join the private game, other players enter the provided 8-digit code. Since we don't want joining players to know the game session ID. We search for the game session using the 8-digit code and then create their player session directly. Only necessary information to join the game session is returned to the client. We need an AppSync GraphQL web API so the game client can access AWS Lambda function. The game client sends the GraphQL's request to create or join a private game. To prevent players sending invalid character and reduce the cost caused by the invalid request, we can use regular expression to check if the player input matches the form of private game code before sending the GraphQL request. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show you both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash /initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms, Linux, ARM64, pick development and the server and package project, and that's it. After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file. And then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project. We can set a position update interval here to convert a WebSocket MMO system to the real time. You can change other parameter based on your use cases. After the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result. We registered two players off screen, test user 1 and test user 2. Test user 1's weapon is changed to the pistol. And the test user 2 weapon is changed to the shotgun. We can see the test user 1's blue character from the WebSocket MMO system. Check out the WebSocket MMO video if you are interested. Now let's create a private game on test user 1's client. The private game code is shown in the top right corner. Let's join the private game using this code on the test user 2's client. We can still see the test user 2's blue character from the WebSocket MMO system on the test user 1's client. Now, Testers 2 has joined a private game, and their silver character appear on the Test User 1's client. Both characters have the weapon they selected earlier. If you're interested, check out the player customization tutorial video. That's all.